my dear learners for this course of engineering graphics. From today we are beginning a new module, that is development of lateral surfaces of solids. Before moving ahead to solve problems on development of lateral surfaces of solids, let us understand the meaning of development. Let us consider any object such as pyramid or prism. The process of unfolding all the surfaces of an object is termed as developing of an object. What I mean to say is that let us consider a cylinder like this. So for a cylinder, we will be knowing what is the diameter of the cylinder, and also we will be knowing what is the height of the cylinder. Let us consider a vertical cylinder like this. Now the process of unfolding all the surfaces of an object is termed as developing of an object. So from one of the point on a rim of the circumference, I will cut this vertical cylinder and I will unfold all the surfaces of this cylinder. So if I unfold the surfaces of this cylinder, I will get a rectangle like this, whose length will be equal to circumference, that is pi times the diameter, and height is nothing but vertical height of the cylinder like this. So the process of unfolding all the surfaces of an object is termed as developing of an object. So once I perform developing of an object, I will get a plane figure. So the plane figure obtained by developing of an object is termed as development. Is called development. In engineering applications, the development is used for fabrication of any objects by using sheet metal. Once I perform development, that is the process of unfolding all the surfaces of an object is termed as developing of an object. The plane figure obtained by developing of an object is termed as development. So once we obtain the plane figure, we will give some alliances in order to fold it. I will give some alliance and I will fold it, and either I will use welding or brazing or soldering in order to connect these two surfaces, that is the alliances. So once I connect this, I will get a hollow cylinder. This is called pattern. The process of obtaining a plane figure by developing of an object using engineering principles and providing alliances is termed as pattern drafting. This is used in fabricating an objects by using sheet metals. So this is about developing of an object and also development. Now development is further classified into 4 different types, namely, next moving for types of development. Moving for types of development. First one is parallel line development. The parallel line development is used for development of an objects such as prism, cylinder and cube. The similarity of these objects is that the vertical surfaces or vertical edges are parallel to the axis. So parallel line method of development is used for development of prisms, cylinders, cube and objects of similar type. To prism, cylinder and cube. So what is the similarity between these objects? The vertical surface or vertical edges are parallel to the axis. So such objects are developed by using parallel line development. Next, moving for second one, that is radial line development. So radial line development is employed for development of objects such as pyramids, cone, and objects of similar type. In case of radial line development, it is employed for development of pyramids, cones and object of similar type wherein which the vertical surface or the vertical edge will be inclined, and all these are connected to a common apex. So such objects are developed by using radial line method. Next, moving for third one, that is triangulation development. Third one is triangulation development. Triangulation development is employed for development of transition pieces. Development of transition pieces. What is the meaning of transition pieces? More than one objects which are of different types connected together. That is, transition piece can be a pipe connected to a tapered section like this. Let us have a circular pipe connected to a tapered section like this. Let this section be square tapered section like this. So two objects of different types are connected. So such objects can be developed by using triangulation development. So triangulation development is employed for development of transition pieces. Next, if I move for fourth one, that is approximate development. Fourth one is approximate development. Approximate development is used for development of objects of wrapped type like sphere, paraboloid, cuboid. So such objects are developed by using approximate development. Approximate development are used for development of wrapped objects. Wrapped objects types such as sphere, paraboloid, hyperboloid, so such wrapped objects are developed by using approximate development. In this course, I will be addressing parallel line development and radial line development, whereas triangulation development and approximate development are out of scope of this course. Now, in today's lecture, let us address a problem on parallel line development. The problem number 1 of our discussion on development of lateral surfaces of solids states that a square prism of base side 30 mm and axis length 60 mm is resting on horizontal plane on its base with all the vertical faces being equally inclined to vertical plane. It is cut by an inclined plane 60 degree to HP and perpendicular to VP and passing through a point on the axis at a distance of 50 mm from the base. Draw the development of the lower portion of the prism. Now, first let us draw the front and top view of the given square prism. The key point to be observed are the prism is resting on HP with all the vertical faces being equally inclined to VP. So the top view of a square prism will be a square, whereas the front view is a rectangle. Now, how to draw that top view? Such a way that all the vertical faces should be equally inclined to VP is the question. So if I draw normal square, then two of the faces, if I draw a normal square like this, then two of the faces will be parallel to VP and two of the faces will be perpendicular to VP, the top view. So therefore this is wrong. Then how to draw? Such a way that I should get all the faces are equally inclined to VP. So I should take corner position like this, and if I draw, I will get all the faces are inclined at an angle of 45 degrees to VP. So this is correct. So top view is a square with corner on either side, which gives us all the vertical faces being equally inclined to VP. So once I draw front and top view, then lay down the cutting plane and then unfold all the surfaces. The process of unfolding all the surfaces is termed as developing of an object. The plane figure obtained by developing of an object is termed as development. Come, let us do for problem number 1. Now, first let us draw top view of the given object. That is, let me draw the top view first. if you draw front and top view of this given object, let me draw VP and HP. Always remember, we will be, unless otherwise specified, we will be always using first angle projection. So if I do that, we will have front view above on vertical plane, top view below on horizontal plane. As I said, I want a square with corner on either side, because we should satisfy the condition that all the vertical faces be equally inclined to VP. For which, let us draw sides of the square whose dimension is given as 30 mm at an angle of 45 degrees on either side. So first I will mark 45 degrees on either side. Mark 45 degrees on either side. Then I draw a line of dimension 30 mm. Drawn. Similarly repeated at bottom. Drawn. Now use the compass, measure the dimension and cut the horizontal. Now if I join, I will get the required square with all the vertical faces equally inclined to VP. Let me correct it properly. So now if we measure the angles, all the angles should measure 45 degrees. 45 degrees on all the four corners. Now, since it is a prism, for prism we will be having base corners and apex corners. So let me call the base as A1 and apex as A. So therefore here I will get A1, B B1, C C1 and D D1. So I draw the top view. Now take the projection and draw the front view. We know the vertical height. The vertical height, that is axis length, is given as 60 mm. So here we will be having the axis as O1. For prism, the longer edges are parallel to the axis. The edge, longer edge BB1 is coming in front of axis O1. So therefore I should give preference for the longer edge BB1. So give preference for longer edge BB1, which is having a height of 60 millimeters. Here we have AA1 having a height of 60 millimeters, and also we have longer edge CC1 having a height of 60 millimeters. Now if I connect, we will get the front view, which is a rectangle of dimension, the diagonal of the square versus 60 millimeters. Now if I mark, this will be A1 dash and this is A dash. Here I will get B1 dash, O1 dash is invisible, and also D1 dash is invisible. Here I will get D dash, which is invisible, O dash, which is invisible, and B dash, which is visible. Here I will have C1 dash, C dash. Now the height of the prism is specified. The height of the prism is given as 60 mm. The height of the prism, the vertical height of the prism is given as 60 millimeters. So this completes the front and top view of the given prism. So once you complete the front and top of the given prism, wherein which the side length is measuring 30 millimeters, so this is a square. This is a square of 30 millimeters. Vertical height, axis height is 60 millimeters. So this completes the square prism of base height 30 mm and axis height 60 mm resting on HP with one of its base with all the vertical faces being equally inclined to VP. Now moving for the next data, it is cut by an inclined plane 60 degree to HP and perpendicular to VP and passing through a point on the axis at a distance of 50 mm from the base. So therefore mark 50 mm height from the base. So this is the base. From base you mark a height of 50 mm. So mark a height of 50 mm. There a cutting plane is passing and making an angle of 60 degree to horizontal plane. So now to extract that, let us mark horizontal plane once again at a distance of 50 mm. So this is at a distance of 50 mm. This is at a distance of 50 millimeters. Mark the cutting plane which is making an angle of 60 degree to HP. It is making an angle of 60 degree to HP. So draw the cutting plane. So inserted the cutting plane. Done. So this is the cutting plane making an angle of 60 degrees with horizontal plane and passing at a distance of 50 mm above the base at a point on the axis O1 dash O dash. Now in order to obtain the plane figure by developing this object, first what we do, first you unfold this sketch completely, that is unfold the square prism. So if I unfold the square prism, what I am going to get, that is, we have a square prism. From one of the longer edge you cut this square prism and unfold all the surfaces. So if I cut it from one of the longer edge and unfold all the surfaces, what is it I am going to get? Yes, you are correct. I am going to get 4 rectangles of dimension 30 cross 60. Correct? We have a square prism like this. We have a square prism like this. So from one of the corner longer edges, if I cut and unfold, I will get 4 vertical surfaces. That is, I will get a development of this square prism as 4 rectangles of dimension 30 cross 60 mm. 30 cross 60 mm. So 4 into 3 will be We have 4 faces, side length is 30. So therefore 4 faces of dimension 30 will yield us 120. So mark 30 each. Mark 30 each. So marking 30 each, I will get let me take projection from here so that the measurement will be correct, and I can show the measurement only once. Done. So now connecting which I have unfolded all the surfaces of this square prism, which yielded 4 rectangular faces, each of dimension 30 mm cross 60 mm, and the overall length of this development will become 120 millimeters. Similarly, if I unfold pentagonal prism, what I am going to get? So pentagonal prism will have 5 vertical faces. So therefore, if I unfold, I will get 5 rectangles of dimension 30. So overall length will become 150. That is correct. Now, in order to transfer the cutting points and retain the lower portion of the prism is what he is stating. Draw the development of the lower portion of the prism. So I want this lower portion, I should remove this upper portion. So to do that, observe carefully, start from each corner, take both longer edge as well as side lengths, shorter edges, that is base edges at bottom as well as at apex. Let us start from A. The longer edge of A is A1 dash, A dash. Is it intersecting by the cutting plane? Yes, it is intersecting by the cutting plane. Mark it as 1 dash. Done. Now inspect whether the base edges are intersecting by cutting plane or not. What is the base edge of A? That is A to B, A1 to B1. So A to B is here, A1 to B1, that is A1 dash B1 dash is here. It is not intersected by the cutting plane, leave it. A dash B dash is here, that is also not intersected by the cutting plane, leave it. Next, move for B. The longer edge is B1 dash to B dash. Is it cutting by the cutting plane? Yes, it is cutting by the cutting plane here. So mark it as 2 dash. Next, go and inspect the base edge. What is the base edge of B? B to C. That is at the base it is B1 dash to C1 dash. It is untouched by the cutting plane, leave it. Apex is B dash to C dash. So when I inspected B dash to C dash, it is intersecting by the cutting plane. So mark it as 3 dash. Mark it as 3 dash. Mark. If the base edge, whether it will be at the bottom or at the apex, if it is intersected, then the intersection point should be measured from the top view. I repeat, if the base edge, whether it is at the base, that is B1 dash C1 dash, or at the apex B dash C dash, if it is cut by the cutting plane, then its dimension should be measured from the top view. Kindly make a note. If it is cut in the vertical plane, no need to worry, just we can take the parallel line. But if it's cut in the base edges, that is side edges, smaller edges, whether it is the base or at the apex, then its dimension should be measured from the top view. So therefore, from 3 dash, you take projection again to measure the dimension. Done. So this will become 0.3. Sorry, it is between B to C. So this will become 0.3. This will become 0.3 for us. Next move for C, that is longer edge is C1 dash to C dash, it is untouched by the cutting plane, leave it. Check for the shorter edge moving from C, it is C to D. So here it is C1 dash to D1 dash, it is untouched by the cutting plane, leave it. Moving at the apex, we have C dash to D dash, yes, it is cut by the cutting plane, so therefore we get 0.4 dash. So since it is cutting the shorter edge at the apex, it should be measured from the top view, so this will become 0.4 as. So this will become 0.4 for us. Clear? 0.4. So that completes C. Next move for D, that is longer edge is D1 dash to D dash. Yes, it is cut by the cutting plane here. So hence mark it as 5 dash. 5 dash. Next check for the shorter edges moving from D, it is D to A. So D dash to A dash is untouched by the cutting plane. Neglect. D1 dash to A dash is also untouched by the cutting plane. Neglected. So this is how you should make marking 1 dash, 2 dash, 3 dash, 4 dash, 5 dash. And find out their locations. If the locations are sighted on the longer edges, no need to worry. Just we can take the parallel line and plot it. If it is sighting on the shorter edges, whether it is at the base or at the apex, it should be measured from the top. So therefore, how much is the length of 0.3 from B and also how much is the length of 0.4 from D is required. So if I measure, I will get it as 12.4 millimeters. I am getting it as 12.4 millimeters. So this length I am getting it as 12.4. So here also if I measure, I am getting it as 12.4. 12.4 millimeters. Done. Now I should transfer this to the development. So for which I will mark the longer edges. So this is neither front view nor top view. No need to use the convention what we were using. That is, for top view we will be using small alphabets without primes, whereas for front view we will be using small alphabets with primes. But this is a development of this square prism. This is neither top view nor front view, so therefore no need to worry about the alphabets. So let me call this as, let me start from A, which means that at longer edge A, I will cut this prism and unfolded all the surfaces. So therefore, I will call this as A1 A, this as B1 B, this as C1 C, this as D1 D, and closing side will be A1 A. Correct? So when I fold it by bending the first longer edge and last longer edge should overlap. After giving some alliances, I will bend it and I will join so that I will get a prism of 4 sides, 4 vertical faces. 4 vertical faces and 2 bottom and top face. Now it is done. For longer edges, as I said, if I have any points in the longer edges, just draw parallel line and transfer. So therefore, if I want to transfer 1 dash is for longer edge A. So just draw the parallel line. Hence, this is called parallel line development. Hence, this is called parallel line development. This procedure can be employed only for prisms, cylinders, and cube, and also objects of similar type for which longer edges or not vertical faces are parallel to the axis. So we have the longer edge A at the beginning and also at the ending. So hence extend it till the end point and mark it as 1. And this is also 1. Done. Next I want point 2. Point 2 is also lying on the longer edge. That is on the vertical line. So directly draw the parallel. No need to worry. So this is for B. So transfer it to B. So transferring it to B, I will get 2. I got 0.2. Next 0.3 is on horizontal line, that is on the shorter edge. Whenever you have cutting on the shorter edge, it should be measured from the top, correct? So therefore this is for B to C. This is for B to C from B at a distance of 3. So at a distance of 12.4 millimeters from B. Between B to C I should mark whether it is at the bottom face or apex face. It is at the apex face. So how much is that? 12.4 from B. So measure 12.4 from B. So I will get here 12.4 from B. This will be 0.3. So this will be at a distance of 12.4 millimeters from B, between B to C. 12.4. So since it is cutting at the top side, I am marking at the top. If it cuts at the bottom, you should mark at the bottom. Hope you follow. Next, locate 0.4. So 0.4 is between C to D, correct? So C to C is unintervened by the cutting plane, whereas the shorter edge C dash D dash is cut by the cutting plane at 0.4 dash. So this is at the shorter edge, so therefore I should measure it from the top view. Yes, you are correct. It is at a distance of 12.4 from D, moving from C to D. So moving from C to D, it is at a distance of 12.4 from D. So therefore measure 12.4 from D. So measuring 12.4 millimeters from D, transfer 0.4. Transfer 0.4 at a distance of 12.4 from D. So this will give us 0.4. Moving for the final point, that is 5. So 0.5 is on D1 dash to D dash, which is the longer edge, and is cutting in the vertical line. So no need to worry, just directly draw the parallel line and locate 0.5. So locate 0.5 directly by drawing the parallel line like this from 0.5. So draw 0.5, then closing side will be 1. Now connect these points and all the longer edges, you will get the required development. That is, first we have from A to 1, next 1 to 2, next 2 to 3, next we have 3 to 4, 4 to 5, then 5 to 1, and 1 to 8. So we have at the bottom A1 to A1. Since it is a square based prism, we have sharp vertical edges rather than. So this is what I will get. So you should bend this properly and give some alliance and correct. So that will give us this solid square prism cut by the cutting plane at an inclined angle of 60 degree to HP. So sorry, I forgot to give the inclination. So this is at an angle of, cutting plane is at an angle of 60 degrees to HP. So this completes the development of the given square prism with the given cutting plane. So the lower portion that which we are going to retain is this one. This is the portion that we are going to retain. So this is how it looks once we join. This development, by giving proper alliance, if I join in the front, it looks like this. That is what I am marking with the blue chalk. So this portion will be retained and this portion will be removed. The development of this is shown here. So this is the solution for problem number 1. This is how we should do development using parallel line method. So that's all from this lecture. Thank you all.